Hello guys, this is Nageshri from Sri Venkateshwara College of Engineering. Today I'm going to talk about a topic in NoSQL. The topic is about key value databases, document value databases and graph databases and their components and characteristics. Firstly, we'll see key value databases. Key value databases are a type of NoSQL database that store a data of a collection of key value pairs. In this model below here, each data item is defined as a unique key and the corresponding values can be any data type ranging from simple strings to complex objects like JSON, document or binary data. If you see below here, the key ID 01 is assigned for value zone. Similarly, ID 2 and ID 3. We'll see the characteristics of key value database. First is simplicity and the schemaless and high performance. In simplicity, key value databases are designed to be simple and effective as they offer a basic interface consistency of operations like put to insert or update a value, get to retrieve a value, delete to remove a value from the structure, and sometimes scan. Schemaless is unlike traditional relational databases, and key value databases typically do not enforce a schema. This means that different records can have different structures. You can store heterogeneous data types within the same databases. Uh, High performance is in key value databases are optimized for high speed data retrieval and write operations because they lack complex querying capabilities and joins. They can handle a large volume of requests with low latency. Now we'll see document value databases. Document-oriented databases, sometimes referred as document stores, are a type of NoSQL databases that stores, retrieves, and manages semi-structured data as a document. Here, the term document in a context typically refers to a JSON or a binary JSON documents, although other formats such as XML may also be supported. If you see here, in a document oriented databases, here is a collection of documents stored. They can be retrieved, managed, etc. The key components of documented databases are document model, schema flexibility, and scalability. In a document model, the document-oriented databases generally stores the data in the form of documents, where these documents are self-contained units of data typically represented in formats like JSON or BJSON. The second is schema flexibility. It is unlike traditional relationship databases where the document oriented databases typically have a flexible schemas. The scalability here in document oriented databases are often designed to be horizontally scalable where they can be effectively handle large volumes of data by distributing it across multiple nodes in a cluster. Now we'll see column families too. It is a column-oriented databases are a type of database management system that store data in column-wise fashion rather than the traditional row-wise approach. In column-oriented database, each column of a table is stored separately on disk as opposed to storing entire rows together. If you see below here the structure of a column family, uh, which contains column key and column value, having a profile and orders, having with a row key. Here are the three key concepts of column databases: data compression, data retrieval efficiency, and better performance for queries. Data compression, since columns typically contain homogeneous data types, they can be compressed more effectively than rows. This compression can significantly reduce storage requirements and improve query efficiency. Data retrieval efficiency in column-oriented databases are optimized for read-heavy workloads such as analytic queries where only a subset of columns need to be accessed. Better performance for aggregation queries. Here, analytic queries often involve aggregative data across multiple rows. We'll see graph databases now. Graph databases are a type of NoSQL databases that use graph structures for semantic queries with nodes, edges, and properties to represent the stored data. Graph databases are generally in a graph structure which are interconnected with nodes and edges. These are the key concepts of graph databases: node, edges, properties, and graph structure. Nodes represent entities in the database such as people, product, or location. Each node typically has a unique identifier and can contain properties which are key value pairs representing attributes of the entity. Edges represent relationship between the nodes. They define how nodes are connected to each other. Nodes edges can also have properties to describe the nature of the relationship between the nodes. In properties, there are key value pairs associated with nodes and edges. They provide additional information about the entities and relationships presented in the graph. Graph databases store data in a graph structure which consists of nodes and edges. Nodes are connected by the edges. This structure allows for the representation of complex relationships and independency between the data elements. So that's it for the video. Thank you for watching.